Okay, hello and welcome back. This is a calculus tutorial and I want to talk about integration by parts, and this is the fifth lesson for integration by parts. I'm going to start off by solving this equation right here because it shows another variation on the process that hopefully you don't get stuck on as you're working through your homework problems. So I'm going to erase this real quick and rewrite the problem again. So I'm going to take the integral of x to the third, and then under the square root sign, I'm going to have 1 plus x squared dx. Okay, if you remember the integration by parts formula, you have the integral f of x, and then you have g prime of x dx. And from manipulating the product rule, that's going to be equal to f of x times g of x minus the integral g of x f prime x dx. Now remember, some times that's shortened down to calling f of x u. So you'd have u, and then g prime of x would be dv, and that would be equal to uv minus the integral of, let's see, that would be v and then du. So they try to shorten it to that notation to make it supposedly easier on you. Maybe it's a little bit less writing, but for me, I actually do like keeping it in f of x and g of x. Anyway, it's really your preference, but lots of times when you see a test, they will refer to it as u's and v's and select which parts for you. But okay, so let's get back to the problem. So looking at this problem right here, we have to figure out which parts do we want to call f of x and which part do we want to call g prime of x. So let's see, this was a little bit of a trial and error process here, because when I first looked at it, I said, okay, obviously I want to take f of x and I want to set that equal to x to the third and then work it out. But when I started to solve for my g of x, and let's so you have your g prime of x, which you select right here. If I was going to start off with just this, I shortly realized that when I did my substitution, where I'd say, this is another reason I don't like to use u and v. So u equals 1 plus x squared, and then du would equal 2x dx. I'd realized that I couldn't really resolve that that substitution, because I'll just finish it out for you. Equals 1 over 2x du. So what would happen is so I'm trying to find g prime. So I'm taking the integral of this to go back. So gx here would then be, let's see, equal to the integral, and because I substituted in there, it'd be u, and then my dx will be 1 over 2x du there. So I'd really have nothing to cancel out this x down here. I could substitute in or solve for x here in terms of u, which is 1, but that would be really complicated. I'd be getting worse rather than better. But looking at my original equation, I realized that I do have x's over here. So if I just borrow one of these and throw it over here, then I do have what I need. Now before I lose my bookkeeping, I borrowed it from here, so I'm going to make this x squared now. So I threw it to this side. Now I do have something to cancel out. So I can cancel out my x's there, and I'm left with the square root of u, and I can take the 1/2, the 2 from here, and the 1/2, throw it to the front, du. Okay? So at that point, life becomes a bit easier, because then I can just say that is just u to the 1/2, and that's a 1/2 out here, du, and that becomes u to the 3/2, 2 over 3 times 1/2. Okay, which equals 2 over 6 u 3/2, which equals 1 over 3 u 3/2. Okay, you see that? So I'm going to take this, I'm going to put it up here just for bookkeeping, and then I'm going to erase this so I have some room to continue the problem. So 1 over 3, and this u, obviously I have to substitute back in. Should have done that down here. 1/3, 1 plus x squared 3/2. There. Okay. So, oops. Oh, that's going to look lovely. Okay. So I'm going to erase this off of here all the way to there. Okay, because you don't really need to see that anymore. Okay, so then I have my f prime of x equals 2x. So now I have all the parts I need to work this equation over here, the integration of parts equation. So let's fill it out. So the integral x to the 3rd square root, I'll just rewrite it one more time, dx, it's that equation right there, equals, now I'm going to take over here and start grabbing my parts, squared, and then that's going to be multiplied by 1 over 3, 1 plus x squared, 3/2, like that. Then it's going to be the other part, minus the integral, and it's going to be 1 over 3. Let's put a bracket around this. 1 plus x squared 3/2. Put a bracket around that I need. And 2x dx. I should have put my dx there, just for good bookkeeping. Okay, so this part of the equation is pretty well taken care of. Right here, I'm just going to probably clean it up just a little bit and just put the 1/3 in the front, x squared okay, no problem. Let me see, I can pull the 2 and the 3 out to the front there, and which leaves me with, oops, let me put in the integral sign there. And that leaves me with x 1 plus x squared 3 dx. And that looks close to what we had originally, but it's obviously going to be another substitution problem here. So this is great. So I can put in a u equals 1 plus x squared, du equals 2x dx. And so dx, just rearranging this a little bit, equals 1 over 2x du. I'm going to substitute that back in, see what I get. Okay, so I have x, and then I have u to the 3 half, and then I put in, for dx, I'm going to put in 1 over 2x du. That x cancels with that x right there, but I'm left with another 1 half. So it's going to be a minus 2 over 6, and just the integral of u to 3 halves du. Okay, so this guy's still carrying down. So 1/3 x squared 1 plus x squared 3, 2. Okay, so I'm running out of room down here. So I'm going to take this guy right here. That integral is actually going to be, let's see, 2 over 5 u 5 over 2 right there. And then substitute back in 2 over 5, 1 plus x squared, 5 over 2. Okay, so that little part right there is going to fill in for this right here. So I'm going to have 2 over 6, we all know, is 1 over 3. 1 over 3 times 2 over 5 times 1 plus x squared 5 over 2. We've got to add in a c. We have 1, 3 x squared 1 plus x squared 3 over 2. So these two combined, that's the last bit, so it's going to be 2 over 15. I'll just save a little bit of writing. There. And that is the answer, hopefully without any mistakes. So I just wrote over my 3. Okay, so hopefully that helps you with these types of problems. The real trick is just right there at the very beginning, recognizing that when you take your integral of your g prime and try to find your g, that using a quick substitution rule, you can borrow from the f of x and rearrange things to make your life easier. So anyway, that's the end of integration by parts for me. I don't think there'll be a part 6, but we'll move on to trigonometric substitutions and that type of stuff. So anyway, good luck. Hope this helps.